Hello, what's up guys, Medium Guy here, and in this video we're going to see the differences between reverse proxy, ingress controller and API gateways. So we'll actually see what they are and what features they have and when to use them and integrate it in your tech stack. So if you're new to the networking ecosystem and you're trying to figure out what networking pieces you need, you've most probably come across the three terms, which are reverse proxy, API gateway and ingress controller. So let's start by breaking down every term, what it is and its common use cases. So getting to know the reverse proxy. You can think of the reverse proxy as that old school phone operator back when there used to be call centers and phone operators. So when someone was picking up the phone, they were connected to a call center. The caller stated the name and the address of the person they wanted to call, and the phone operator connected them. A reverse proxy does a similar job by receiving user requests and then forwarding said requests to the appropriate servers. So as you can see in the picture over here, we've got some users through the internet. Their requests are somehow received by the reverse proxy, and deciding on the request, maybe by the domain name or the path of the request or factors like this, the reverse proxy will then forward the request to one of the servers that it is configured with, so it will receive the response from that server and then send the response back to the client. So as I mentioned earlier, reverse proxies route user requests to the appropriate servers, assuming that you are utilizing multiple servers. So naturally, those of you using a single server are probably wondering whether or not it makes sense for you to even implement a reverse proxy. In fact, reverse proxies are useful even in single server scenarios where you can take advantage of the features like rate limiting, IP filtering, and access control, authentication, and caching and things like that. So actually you can implement all these in your application, but this will be out of the scope of your application and it'll just add some other layers of complexity to your application. So why not use a reverse proxy to handle all these functionalities in a separate service? So as you can see, even if you have a single server, the users will make their requests, which will then be received by the reverse proxy. Then it will check the configurations that you configured it with. So like for example, it can check the rate limiting based on the client's IP addresses, or it can actually restrict requests to some paths, let's say /admin, again maybe based on the user's IP address. So next, let's get to know the ingress controller. So in a nutshell, an ingress controller is a reverse proxy for the Kubernetes universe. It acts as a reverse proxy, routing traffic from the outside world to the correct service within the Kubernetes cluster. To better understand this, let's take a step back first and look at the ingress itself. A Kubernetes ingress is an API object that determines how incoming traffic from the internet should reach the internal cluster services, which then in turn send requests to a group of pods. The ingress itself has no power over the system. It is actually a configuration request for the ingress controller. So as you can see in the picture over here, we've got a Kubernetes cluster that has multiple services which are backed by multiple pods, and as you can see we have multiple ingresses also, each one routing the requests to the relevant services. So as you can see, we can have multiple ingresses that will support multiple domain names, or actually it can also route based on the path of the requests. So ingress controllers are used to expose multiple services from within your Kubernetes cluster to the outside world using a single endpoint, for example a DNS name or IP address. Specifically, ingress controllers are used to expose multiple services under a single DNS name, implement path-based routing where different URLs map to different services, implement host-based routing where different host names map to different services, implement basic authentication or other access controller methods for your applications, implement rate limiting for your applications, and SSL and TLS termination for your applications to the ingress controller. So right now we get to know a little about API gateways. Deployed at the edge of your infrastructure, an API gateway acts as a single entry point that routes client requests to your backend microservices. Essentially, an API gateway is a reverse proxy handling incoming user requests. So as we can see in the picture over here, we've got the clients making the request that is received by the API gateway, and then it routes the requests to the REST APIs that it is configured with based on the client's requests. So suppose you have multiple microservices and your application is actually serving both to a web application and also to mobile applications. Also suppose your application exposes APIs to third-party applications. So in architectures like this, it is good to have multiple API gateways that are backed up by the relevant microservices, and they are actually handling all the requests to your microservices based on the client's requests. So API gateways are commonly used in architectures where you need to expose multiple microservices to the outside world through a set of APIs. So on top of the functions we already saw as part of a typical reverse proxy, API gateways can handle load balancing, rate limiting, access control, SSL termination, caching, request and response transformation, logging and monitoring. Also, API gateways come with a few extra handy functionalities, namely service discovery, circuit breaker, and request aggregations. So I'm not going to cover much about these concepts, but here is a brief explanation about each. So service discovery is a process of automatically detecting services on a network. It solves the problem of how you connect the applications in your network. Without service discovery, people have to manually input the addresses a client app requires to send requests to other app or servers. This means they have to maintain a long list of static addresses, which is feasible for small projects but impractical in large environments. So service discovery automates this process and stores addresses dynamically in a service registry so services can locate and communicate with one another more easily. Also, circuit breaker concept is like when you have applied the microservices architectures and services sometimes collaborate when handling requests. When one service synchronously invokes another, there is always the possibility that the other service is unavailable. So in this case, it is more likely for the caller service to exhaust in its threads or resources or things like that, and it won't actually be able to respond to the client requests. So circuit breaker comes into play and actually causes the service getting into these situations. Also, gateway aggregation pattern is when a client makes a request that is received by the service, and in order to return the relevant response for the client, it actually needs to make some more requests to some other services. So you can use a gateway to aggregate multiple individual requests into a single request. So let's get back to our topic, and to bring everything together, in essence, an ingress controller does the same job as a reverse proxy or an API gateway when it comes to handling incoming traffic and routing it to the appropriate service. However, the ingress controller operates at a different level of network stack, which is the Kubernetes environment. In that sense, the ingress controller is a specific type of reverse proxy designed to operate with Kubernetes clusters. Just as the API gateway sits at the edge of your infrastructure, the ingress controller sits at the edge of the cluster, listening for incoming traffic, and then routes it to the appropriate Kubernetes service within the cluster. So to sum up, it is actually considered a best practice to make use of each of these concepts and actually not make the backend services exposed to the internet directly. So that's all for this video, and I hope you learned something new in this one. And if you have any questions, any recommendations, go ahead and ask me in the comment section down below. And if you liked the video, please don't forget to like and subscribe, which will help grow the channel and motivate me to make more free contents like this. So thanks for watching, and I hope to see you in the next videos.